So I'm going to zoom in here. This we can subtract these, and these are similar problems. If we factor out an x in this case, x plus 1, so we see that there are in fact common elements to the denominator. What's this missing is another x. So if I multiply the top and the bottom by x, I end up with a 6x over this common denominator, which is x times x plus 1. At that point, then, I can subtract this numerator. It's a 6x. So I got a 7x minus 6x, if I write that out. 7x plus 1 minus 6x over, and if I look at the denominator, which they have in common is an x plus 1, that numerator becomes, 7x minus 6x is equal to 1x, or x plus 1, over this denominator of x times x plus 1. Now, you look at that, and there's a coefficient of 1 out in front. If I reduce what I can reduce, it's the x plus 1s, because anything over itself is equal to 1. I end up with a 1 over x, which is my answer here. If you look at something like this where it's divided by, you can divide by a fraction, but it's the same thing as multiplying by the reciprocal. So this thing, if I change divided by to a times, and this gets moved up top, and then we can just start reducing. I'm going to factor as I do it, though. This difference of two perfect squares can be factored by conjugates. So this is a 2x plus 1 and a 2x minus 1. If I move this guy down yonder here, I can take out a 3, because the 3 is the only thing they both have in common. I'm left with a 2x plus 1. Okay, and that's familiar here. I can reduce that right from the get-go, but something we can also do at a later date after we do all the factoring. So two numbers that multiply together to get a positive 4, but add together to get a negative 5. That's a negative 4 and a negative 1. So x minus 4 and x minus 1 are my factors. And as you kind of look through this, certain things can be factored here. If I will say this, that a 2x minus 1, if I know that that's a possible factor, I can say what times what is equal to 2x. Well, I can say 2x times x is going to give me a 2x squared. And what times negative 1 is equal to a positive 1? Well, that could be a minus 1. I got to make sure that I check the outer and the inner. That's a negative 1x and negative 2x. Add those together, you get a negative 3x. I looked at that as a possible factor of this, and it turns out that was the case. I could also then reduce my x minus 1s, leaving me with an x minus 4 on top over the 3 on the bottom. This one here is similar to the first, in that if you factor this, you got an x minus 4 times an x plus 2. So what we need here is an x plus 2. Sorry, we'll do that over on the other side. I got a little carried away. So this was already the denominator. Over here, I need to include x plus 2 as a denominator. So x plus 2 times 1 is just going to remain an x plus 2. Then I have to subtract the 6. So x plus 2 minus 6 is going to give me a grand total of x minus 4 on top. And my denominator that already has an x minus 4 and an x plus 2, this portion of it can be reduced, but remember my coefficient of 1 out in front still exists. So I have a 1 over x plus 2. And this really is the same as this. It can be factored and reduced, conjugates and whatnot, but take out an x to the 4th power, top and bottom, and I'll leave that one for you.